These are some typical growth trajectories of companies that we consider successful. The hockey stick trajectory being the most popular and sought after one amongst all of them. The software systems that worked well during the initial phases of a company, phase A in this graph, will not be sufficient in phase B as you prepare to scale your business. The exponential growth phase, phase C, requires drastically different software capabilities than phase A or B. I'm making the case that successful companies, the kind that live to see growth, outgrow their software systems in one way or the other. Which brings me to my first takeaway. Legacy systems are a byproduct of success. Despite being a byproduct of success, legacy systems have a bad rep. Just the term legacy evokes strong emotions among engineers and business folks alike. And this is for good reason, because we associate legacy systems with high maintenance cost, a lot of tech debt, painful migrations, and poor developer experience. Given legacy systems are inevitable in successful companies, we should build the muscle to not let legacy systems weigh us down. And this is critical for continued success of your organization. And that is my second takeaway. Transform legacy systems for long term success. In fact, this takeaway is the inspiration for this talk. Renovate to innovate, the fundamentals of transforming legacy architecture. I'm Rashmi Venugopal, a staff engineer at Netflix, and I spent the last decade building and operating reliable distributed systems at scale. I'm excited to be speaking at Apidays London, so thank you for having me. We'll begin by unpacking legacy systems, what they are, why they exist, etc. The focus of this talk is on technical renovation. We'll cover what it means, when a technical renovation is applicable, and strategies for an effective renovation. Think of the first few things that come to mind when you think of the word legacy. I'm going to show you OpenAI's word cloud for the term legacy. Do you see any of the words that came to mind for you? As you can tell, the term legacy is quite overloaded. So let's spend a couple of minutes to get on the same page about what legacy systems mean in the context of this talk. I define legacy systems as the ones that are incapable of keeping up with business requirements. Let's talk about a few symptoms of legacy systems to make this more concrete. There are numerous dimensions of complexity in software engineering. Legacy systems usually have substantial complexity in one or more of these dimensions. Working across a large number of teams slows engineers down because of coordination tax, and that is organizational complexity. Operational complexity is when there is insufficient investment in observability, automation, or testing, leading to high operational cost. Cognitive complexity is when institutional knowledge builds up as documentation gets outdated or people leave and come. But hey, why is too much complexity a bad thing? Because as complexity goes up, innovation velocity goes down. There is a direct correlation between complexity and innovation velocity. Folks on the business side expect productivity to scale linearly with complexity. Engineers know better. We're close to the ground, and our past experience has primed us to be more pragmatic. It is a symptom of a legacy system when the reality of how long it takes to roll out a change far exceeds expectations in a bad way. Another sign of legacy systems is degraded quality of experience. Quality of experience measures the overall satisfaction of end users as they interact with the system. I'm sure we've all experienced the very real frustration of waiting many seconds for a screen to load. Amazon has an infamous study that quantifies the impact of latency on their business. They find that every 100 millisecond increase in latency impacts their sales by 1%. A dip in quality of experience, despite our best effort to tune them, is a symptom of a legacy system. To recap, I consider systems that are unable to keep up with the business requirements as legacy. And these parameters are ones that weigh you down. Okay, now that we've covered what legacy systems look like, let's talk about why software systems become legacy in the first place. The most obvious reason is the rapid pace at which technology advances today. We've seen how quickly technology has evolved in the communication space. Systems that were once considered cutting edge struggle to keep up with modern industry standards just a few years down the line as their technology choices become outdated. In addition to this obvious reason, there are two schools of thought that explain software degradation. The bit rot theory. It states that software gradually degrades over time due to incremental changes to itself or its surroundings. The primary driving factor here is the informed and intentional trade offs that engineers make to meet deadlines and deliver results faster. Code duplication is an example. Lack of documentation or loss of knowledge is another example. Bit rot can be kept in check by following software engineering practices, but despite our best efforts, it will accumulate over time. The second school of thought is the law of architectural entropy. It states that software systems eventually lose their integrity when features are added without consideration of the original architecture. Imagine the growth of an e-commerce company. In the early stages, they're focused on establishing a successful business. Evolving their architecture to be perfect is not a priority. In fact, changes to the software architecture is driven by business needs, and it needs to evolve very quickly to incorporate the functionality that is deemed necessary for success. And in this example, every new feature is added to an existing monolith, steadily increasing the architectural entropy. In the real world, software systems are affected by all of these phenomena. This explains why outdated and legacy systems are more commonplace than we'd like them to be. Okay, now that we've established and agreed that legacy systems are common, let's ask ourselves, do we always proactively renovate and improve our legacy systems? I wish. The inevitability of software degradation on one hand, combined with the lack of proactiveness on the other, leaves us with systems that are difficult to understand, maintain, and extend. This brings us to technical renovation. What does technical renovation actually mean? I define technical renovation as the act of upgrading or replacing outdated systems and technology to improve system health. Often, I get asked, hey, what about refactoring? How does refactoring fit into technical renovation? Refactoring is like organizing your closet. Organizing involves moving things around. It makes it easy to access all pieces of clothing. You might even get rid of some stuff to make room for new things. And it also has the side effect of reminding you what you already have and might influence your future wardrobe investments. Sticking with the closet analogy, renovation is when you break down the walls to replace your regular closet with a walk in one. Renovation goes beyond just moving things around. Renovation is when you make a drastic change that shakes things up, and the end result gives you capabilities that you did not have before. Renovation is a much larger undertaking and occurs less frequently than refactoring. That said, refactoring is valuable and it is a valid strategy to maintain a healthy code base. I just wanted to put that disclaimer out there. Now that we've established what technical renovation is and how it's different from refactoring, let's review some scenarios where technical renovation is most applicable. In other words, if technical renovation were a hammer, what are the nails? As your business needs evolve, attempting to reuse the existing systems to solve for a drastically new use case introduces complexity. Here's an example of a business driven renovation. Netflix evolved from a DVD distribution company to a streaming service. The capabilities required to deliver DVDs is very different from the capabilities required to stream video on demand. So the systems that served Netflix well in the DVD era isn't going to be sufficient to run a successful streaming service. This drastic change in business needs eventually called for a technical renovation. Technical renovation is a valid strategy for an ecosystem driven need, like modernizing your technology stack. Let's say you're migrating from REST APIs to a GraphQL gateway. A renovation is in order. Just refactoring isn't going to cut it. Sometimes software systems turn out to be more successful than anyone imagined they would. While that's specifically a good problem to have, the unexpected longevity accumulates significant tech debt. And this makes technical renovation a valid option to improve the state of the software system and architecture. And these are some nails for the hammer that is technical renovation. My third takeaway is use the right tool for the right problem. Leverage renovation for the scenarios similar to the ones we just discussed, and use refactoring when it makes sense to do so. All right, now let's talk about how to approach a technical renovation. I'd like to share 4 strategies to maximize the success of your renovation initiatives. Make it work, make it right, make it fast. This quote from Kent Beck encapsulates my approach to any new work, not just renovations. It is my first strategy for a good reason. Technical renovation is a huge undertaking. Prioritizing can be a daunting affair. Just identifying what we should be doing first and what can be left for later is a question that has kept me up at night. Ken suggests that our first priority should be to focus on making it work. Beat the analysis paralysis by doing the simplest thing that just works. You're not a business without a system that doesn't get the job done. Then make it right. This is a good time to prioritize adaptability, extensibility, and readability. This is when you have to be mindful to resist the temptation to over engineer. As a rule of thumb, if you don't regret any of your early decisions, chances are you over engineered. Finally, make it fast. Now is the time to prioritize performance. Make the necessary tweaks to hit the quality of experience metrics that are table stakes to serve your business well. This structured approach to tackling the various aspects of a technical renovation helps break up a daunting endeavor into manageable milestones. This approach just gives me the clarity that I need to focus on the right things at the right time. The second strategy is evolutionary architecture. Internalize the fact that complex systems cannot be fully designed upfront. Building software in a rapidly changing environment comes with many unknowns. So start by identifying a set of fitness functions that represent the desired quality of your end state, such as performance, security, or scalability. Once you've picked the system qualities that matter most to you, use that as your guide in decision making. Make trade offs that align with your priorities. Once you know what matters most to you, focus on creating an infrastructure that you can use for continuous experimentation. Automate the steps between developing a feature and releasing a feature. This will help your team experiment their way into making changes. And this is key for innovation velocity. Now that you have the infrastructure to release changes quickly, focus on making incremental changes. Making changes in a big bang is difficult to get right, especially when something goes sideways, which it will sooner or later. So make incremental changes so that you can iterate and course correct as you go. The cycle of evolutionary architecture involves making incremental changes to validate your architecture against your fitness functions, and then releasing changes quickly to experiment and course correct by making more incremental changes. In summary, building an evolvable architecture is critical for the long term success of your renovation initiatives. The third strategy is deprecation driven development. This focuses on what we gain from deprecating as opposed to what we lose. This approach makes the case that systematically removing obsolete technology is a prerequisite for a healthy software engineering lifecycle. Be honest about components that are better off left in the legacy systems, because the return on investment doesn't justify the effort required to renovate them. These could be features that are in maintenance mode or products that do not contribute significantly to the business. Netflix winding down DVD.com is a good example of a product deprecation that was driven by business trade offs. As the DVD business continued to shrink, it became increasingly difficult to justify the cost of providing the best service experience for Netflix DVD members. The fourth strategy is intentional organization design. Innovation is equal parts discovering new products and iterating to improve existing ones. An inspiration for discovery or iteration can occur in any part of the company. So, making it easy for ideas and inspiration to flow through the organization is important for innovation velocity. In addition to flow of ideas, organization design also has an impact on software architecture. And Conway's law explains the synergy between the two. The structure of the software architecture will mirror the structure of the organization that built it. So, for an organization undertaking a technical renovation initiative, it is a good idea to first take a step back, assess the org structure, identify any changes that might be beneficial for streamlining communication and minimizing cross team coordination. Let's look at an example of organizing teams. Design A groups engineers based on their functions, like front end, middle tier, back end, etc. Design B groups engineers based on common deliverables, such as full stack teams. Each design has its pros and cons. A optimizes for engineers to ramp up quickly and provides a space for them to become experts at their craft. But if every new functionality requires making changes to all three parts of the stack, they will need somebody outside their team to manage dependencies and line up tasks. In that case, B might be more efficient. In summary, you have to choose to strengthen the communication parts that are most important for the nature of your organization and its software architecture. Because every communication path cannot be the strongest. While this brings us to the end of the strategies I have for us today, I'd like to talk about a critical piece of the puzzle that is important for all the work required in a technical renovation to actually come together: the growth mindset. The principles I shared today may seem ambitious, and that is because they're intentionally aspirational in the spirit of shooting for the stars and landing on the moon. But also because there are no silver bullets for technical renovation, only strategies. The ideal approach to renovation is highly context dependent. Your strategy and decisions should be deliberated on a case by case basis to account for the unique circumstances and challenges that are relevant for you and your organization. Regardless of how well debated and well thought out your strategy is, you can rest assured that your path to transforming legacy architecture will be a thorny and bumpy one. So embrace the growth mindset, seek feedback, learn from your mistakes, and focus on continuously improving throughout your renovation journey. And that brings me to my final takeaway: renovate, reorient, and repeat. Thank you all, and I wish you luck on your personal transformation journeys. Bye.